Imagine a planet far, far away from our own home. Let's call it Xylos. This isn't just any world. Its atmosphere is alive. The sky shimmers with a beautiful, eerie green light, and the clouds aren't just water vapor. They are massive, slow-moving organisms that drift through the air like giant sky whales. These living clouds can change the air around them, creating pockets of strange gases and sudden shifts in weather. The surface of Xylos is a wild place, covered in glowing crystal forests and bubbling geysers that shoot hot, colorful steam into the air. It's a place of incredible wonder, but also one of extreme danger. Exploring a world like this is a dream for scientists everywhere. To understand a world like Xylos, we can't just look at it through a telescope. We need to go there, or at least send something in our place. That's where our amazing smart robots come in. These aren't just remote-controlled cars, they are autonomous explorers designed to think on their own. They are our eyes, our ears, and our hands on this distant, mysterious planet. Their mission is to travel across the strange landscape, study the living atmosphere, and send back all the incredible secrets they uncover. They are built to face the unknown, to survive in a place where no human could, and to help us answer the biggest question of all: are we alone in the universe? Studying a planet with a living atmosphere is a unique challenge. Every gust of wind could be a biological process, every change in the air a sign of life. The very weather on Xylos might be the planet breathing. This makes our mission incredibly exciting. The data our robots collect could rewrite everything we know about biology and planetary science. We need to measure everything, from the faintest whisper of wind to the most intense heat from a volcanic vent. Every piece of information is a clue in the grand puzzle of this alien world, helping us piece together the story of its existence and its strange, beautiful living sky. Our journey to Xylos is more than just a scientific mission. It's a journey of human curiosity. For centuries, we have looked up at the stars and wondered what's out there. Now, with the help of these smart robots, we are finally reaching out to touch those distant worlds. We are extending our senses across millions of miles of empty space. The robots on Xylos are an extension of us, of our desire to explore, to learn, and to understand our place in the cosmos. They are pioneers on a new frontier, and the discoveries they make will inspire generations of future scientists, dreamers, and explorers to keep looking up and asking what's next. So why do we care so much about temperature and pressure? Well, think about it like this. When you go outside, you check the weather. Is it hot or cold? Is it windy? These things tell you what to wear and what to expect. On an alien planet like Xylos, temperature and pressure are the two most important parts of the weather. They tell us what the environment is really like. Is it a calm, stable place, or is it a violent, chaotic world with crushing pressure and extreme temperatures? These two measurements are the fundamental building blocks for understanding any planet's environment and whether it could ever support life. Temperature is especially important. Life as we know it can only exist in a very specific range of temperatures. If it's too hot, complex molecules break apart. If it's too cold, chemical reactions slow down to a crawl. By measuring the temperature all over Xylos, our robots can create a heat map of the planet. This map can show us where the hot spots are, like near those bubbling geysers, and where the cold spots are, perhaps in deep shadowed canyons. Finding a place with a stable, moderate temperature, what scientists call a Goldilocks zone, could be the first clue that we've found a potential habitat for alien life. Pressure is just as critical. Atmospheric pressure is the weight of the air pushing down on you. Here on Earth we are used to our planet's pressure, but on another world it could be very different. The pressure on Xylos could be so high that it would crush a robot not built to withstand it. Or it could be so low that liquids boil away at room temperature. By measuring pressure, robots can tell us about the planet's atmosphere, how thick it is and what it's made of. Sudden drops in pressure can also warn of powerful storms approaching, giving our robots time to find shelter and protect their delicate instruments. Together, temperature and pressure tell a story. They reveal the planet's energy system, how it absorbs heat from its star, and how it moves that heat around through its atmosphere and oceans, if it has any. This flow of energy drives everything from the weather to potential geological activity. Understanding this dynamic system is key to predicting what the planet will do next. It helps scientists build models of the planet's climate, which can then be used to guess where to look for interesting features like underground water or even signs of simple microbial life. These two simple numbers open up a world of possibilities. The robots we send to worlds like Xylos are incredible machines. They are not like the robots you see in movies. They are built for one thing: survival. Imagine a tough metal explorer that looks a bit like a futuristic armadillo. It might have 6 or even 8 rugged wheels, each with its own independent suspension, allowing it to crawl over sharp rocks and climb up steep, dusty hills. Its body, or chassis, is made of super strong but lightweight materials like carbon fiber and titanium alloys. This shell is designed to protect all the important electronics inside from extreme temperatures, radiation, and even from being hit by flying debris during a storm. These robots are more than just tough, they are also incredibly smart. They are equipped with a whole suite of scientific instruments, but their most important tools are their sensors for real-time data collection. These sensors are constantly working, tasting the air, feeling the ground, and measuring the world around them every second. This information is processed right there on the robot by a powerful onboard computer. This computer acts as the robot's brain, using artificial intelligence to make decisions on its own. It doesn't need a human to tell it where to go next. It can analyze the terrain ahead and choose the safest and most interesting path all by itself. Powering these robotic explorers is a huge challenge. On a distant planet, you can't just plug them into a wall socket. Many of our planetary rovers, like those on Mars, use a radioisotope thermoelectric generator, or RTG. This is like a nuclear battery. It uses the heat from the natural decay of a radioactive element like plutonium-238 to generate a steady supply of electricity. An RTG can power a robot for many, many years, allowing it to work day and night through long, dark winters and in dusty conditions where solar panels wouldn't be very effective. This reliable power source is what makes long-term missions possible. The design of these robots is all about being prepared for the unexpected. They often have redundant systems, meaning they have backups for their most important parts. If one camera breaks, a backup camera can take over. If a wheel motor fails, the other wheels can compensate and keep the robot moving. This resilience is crucial for missions that are millions of miles away from the nearest repair shop. Every part of the robot, from its sturdy wheels to its brilliant AI brain and its long-lasting power source, is engineered to keep it exploring, learning, and sending valuable science back to us here on Earth. So how does a robot actually measure pressure on a planet like Xylos? Well, it uses a special tool called a pressure sensor or a barometer. Inside this sensor is a very small, flexible diaphragm, which is basically a thin, circular piece of metal or silicon. This diaphragm is sealed inside a tiny chamber with a vacuum on one side, meaning there is no air in it at all. On the other side is the alien atmosphere. The pressure of the atmosphere pushes on the flexible diaphragm, causing it to bend inward. The higher the pressure, the more it bends. It's kind of like pushing your finger into the top of a balloon. The robot's brain can measure exactly how much this tiny diaphragm is bending. It does this by using something called a strain gauge. A strain gauge is a sensor that changes its electrical resistance when it is stretched or compressed. As the diaphragm bends under the atmospheric pressure, it stretches the strain gauges attached to it. The robot sends a small electric current through these gauges and measures how the resistance changes. By precisely calculating this change, the robot's computer can determine the exact atmospheric pressure outside. It's an incredibly sensitive and accurate way to feel the weight of the air. This data is, honestly, incredibly useful for mission safety. On Xylos, where the atmosphere is alive and unpredictable, sudden pressure drops could be the first warning of a massive storm rolling in. The living clouds might create areas of extremely low pressure, causing violent winds to rush in. By monitoring the pressure continuously, our robots can see these changes happening in real time. The robot's AI can then say, "Hey, the pressure is dropping fast. A storm is coming from the west. I need to find a safe place to hide, like behind that big rock formation over there." This gives the robot time to protect itself. But pressure sensors do more than just predict storms. They also help scientists understand the structure of the atmosphere. As a robot climbs a mountain or descends into a deep valley, the pressure will change. By combining pressure data with altitude data, scientists can calculate the density of the atmosphere. This tells them how thick the air is at different heights, which is vital information for planning future missions, especially for flying drones or landing spacecraft. On a world like Xylos, it could even reveal how the living clouds influence the layers of the atmosphere, creating a unique and complex weather system unlike anything in our solar system. Just as important as feeling pressure is taking the planet's temperature. Robots do this using a variety of heat sensors. One of the most common types is a thermometer, but not the kind you have at home. These are electronic thermometers, often using a device called a thermistor. A thermistor is a special resistor whose electrical resistance changes significantly with temperature. The robot's computer sends a tiny electrical current through the thermistor and measures its resistance. Based on that measurement, it can calculate the surrounding air temperature with incredible precision, whether it's hundreds of degrees below zero or hot enough to melt lead. But our robots don't just measure the temperature of the air, they also need to measure the temperature of the ground and other objects from a distance. For this, they use infrared cameras or radiometers. Everything that has a temperature above absolute zero gives off invisible light called infrared radiation. The hotter something is, the more infrared radiation it emits. The robot's infrared camera can see this energy and create a picture based on heat instead of visible light. This allows the robot to build a thermal map of its surroundings, showing which areas are hot and which are cold. This thermal mapping is, honestly, essential for predicting geological events. On Xylos, the ground might be unstable, with hidden magma chambers close to the surface. An infrared camera can spot these dangerous hotspots long before the robot drives over them. It can see the ground heating up, which might be a sign that a geyser is about to erupt or that a new volcanic vent is about to form. The robot's AI can analyze these thermal images and warn the mission team back on Earth. I'm detecting a significant temperature increase in the ground ahead. This area may be volcanically active. I'm going to find a different route. The data from these heat sensors also provides clues in the search for life. On Earth, we find life thriving near hydrothermal vents at the bottom of the ocean, where hot mineral-rich water provides energy. By using its infrared sensors to find similar geysers or warm springs on Xylos, a robot can identify prime locations to search for extraterrestrial biology. A spot that is unusually warm and stable could be a habitat where life might be hiding. By guiding the robot to these promising locations, heat sensors act as a divining rod for astrobiologists, pointing them toward the places where a monumental discovery might be waiting. One robot exploring an alien world is amazing, but a whole team of robots working together is a complete game changer. On a planet like Xylos, we wouldn't just send one explorer, we'd send a fleet. These robots form a network, constantly talking to each other. They don't use spoken words, of course. They communicate using radio signals, creating their own local Wi-Fi network. This allows them to share information instantly. If one robot finds a dangerous patch of soft sand, it can immediately send a warning to all the other robots in the area. Danger. Unstable ground at these coordinates. Avoid this spot. This teamwork makes the entire mission much safer and more efficient. This network isn't just for sharing warnings, it's for sharing discoveries too. Imagine one robot, a specialist in geology, is analyzing a rock. It finds a strange mineral it doesn't recognize. It can send the chemical data to another robot nearby, one that specializes in biology. The biology robot can then move to that location and use its microscope to see if any microbes are living on that mineral. This collaboration allows the robots to follow up on interesting finds much faster than if they were working alone. It's like having a whole team of scientists in the field, each with a different specialty, all working together on the same problem. This network of robots is also smarter together than any single robot is on its own. They use a concept called distributed computing. This means they can share their brainpower to solve complex problems. For example, to predict the movement of those giant living clouds in Xylos's atmosphere, one robot's computer might not be powerful enough, But by linking together, 10 robots can combine their processing power to analyze the huge amount of data from their sensors. Together, they can create a much more accurate weather forecast for the entire region, something none of them could do alone. This collective intelligence is a powerful tool for exploration. Getting all this incredible information back to Earth is the final, crucial step. The robots don't all have to send their data directly to us, which would use a lot of energy. Instead, they can send their findings to a central base station robot or an orbiter flying high above the planet. This main communicator gathers all the data from the team and compresses it. Then, it uses its large, powerful antenna to beam the information package across the vastness of space to the eager scientists waiting back home. This system is efficient, reliable, and ensures that every precious bit of data from our robotic team makes it back to Earth safely. As we look to the future, the exploration of alien worlds won't be about single, lonely robots. It will be about creating vast, autonomous networks of explorers that cover an entire planet. Imagine hundreds or even thousands of specialized robots swarming across the surface of a world like Xylos. Some will be crawlers built to explore canyons and caves. Others will be flyers like smart drones, mapping the atmosphere and studying the living clouds up close. There might even be burrowing robots that dig deep into the ground, searching for underground water or signs of ancient life frozen in the ice. This future fleet of robots will be completely self-sufficient. They will be able to manage their own power, finding sunny spots to recharge their batteries or huddling together near geothermal vents to draw energy from the planet's heat. They will even be able to repair each other using robotic arms to replace broken parts or fix damaged wiring. This level of autonomy is key to exploring worlds that are light years away, where communication with Earth could take decades. The robots will have to be true pioneers, capable of surviving and thriving on their own for centuries. The ultimate goal of these robot networks is to prepare these worlds for potential human visitors and to help us understand our universe. The robots will create incredibly detailed maps, identifying the safest places to land a future human mission and pinpointing where to find resources like water ice or useful minerals. They will monitor the planet's weather and geology for years, building up a complete picture of its environment. This knowledge will be essential for keeping future human explorers safe. The robots will be our scouts, our guides, and our guardians on these new frontiers. This vision of the future is incredibly inspiring. It's a future where our curiosity is no longer limited by distance or danger. Through these intelligent and cooperative robotic networks, we can extend our presence across the galaxy. We can uncover the secrets of countless new worlds, search for life in the most unexpected places, and answer the most profound questions about the cosmos. The journey begins with simple measurements of temperature and pressure, but it leads to a future where humanity, with the help of its robotic partners, becomes a truly interstellar species. The adventure is just beginning.